light of wavelength 500 nanometer is incident on a metal with a work function 2.28 electrovolts. The de Broglie wavelength of the emitted electron is. Okay, we need to find here the de Broglie wavelength of the emitted electron. Given the energy of the photon E is calculated using the equation, that means E is equal to, we know that hc divided by lambda, where H is the Planck's constant, c is the speed of the light, and lambda is the wavelength of the light. By substituting the values of this one, we get E is equal to, all these are constant values, that is 6.626 into 10 to the power of minus 34, and the speed of the light is 3 into 10 to the power of 8 whole divided by lambda value is equal to, they are given, that is a 500 nanometer, that is a 500 into 10 to the power of minus 9. Then by simplifying, we get the value that is equal to 0.0397 into 10 to the power of minus 21 joules of energy. To convert this energy into electron volts, that is EV, then E is equal to 0.0397 into 10 to the power of minus 21 whole divided by, that is 1.6 into 10 to the power of minus 19. Then we get the answer 0.0248 into 10 to the power of 2 electrovolts, which is nothing but 2.48 electrovolts. Then according to the Einstein's photoelectric equation, that is Ke max, which is equal to E minus W, that is equal to 2.48 EV minus, they are given, the work function is 2.28, that is 2.28 EV, we get the answer 0.2 EV. For the de Broglie wavelength of the emitted electron, that is lambda E minimum, which is equal to 12.27 divided by under root of kinetic energy, that is the maximum kinetic energy in terms of electron volts, which is equal to 12.27 divided by under root of, we get the maximum kinetic energy is 0.2, then we get the answer 27.436 A. Then Armstrong, we will convert it, then this becomes in terms of meter 27.436 into 10 to the power of minus 10 meters. Thus, the minimum wavelength of the emitted electron is, that is lambda minimum is equal to 2.7436 into 10 to the power of minus 9 meter, that is lambda value, it is greater than or equal to lambda minimum, then we can say here it is a greater than or equal, then option D is the right answer.